In this video, we're going to look at the different ways that two equations can interact with each other, giving us three different solution types. I've come up with an investigation to illustrate the three different possibilities of solutions for systems of equations. And once you graph each set, graph 1, 2, and 3, you'll then describe what you've done, count the number of POIs, and come up with a name for the situation that you have. You can pause the video and come up with the graphs on your own, or watch me do it. So for me to graph a system of equations or any line, I like to use y equals mx plus b. And my first equation, b is 5, and m, or slope, is negative 1/2. Then I go over to my graph. There's 5. Slope is down 1 over 2, so down 1 to the right 2, fall 1 to the right 2. Give myself a series of guide coordinates so I can draw a nice straight line. And there they are. And here is my first line of my equation. All right, my second equation is not in the right form, so I'm just going to manipulate it a little bit. Take the y and push it to the left. The negative becomes positive. And now to isolate that y, divide both sides by 2. The 2's cancel out and become 1. And you get y equals x over 2, which can turn into y equals 1/2 x. And there's no b, but you can put in 0 as a placeholder. And so now with this equation, you've got b equaling 0 and m equaling positive 1/2. So now over to the graph. B is 0. B is 0. And slope is up 1 to the right 2, up 1 to the right 2. And I can draw my line. I'm not going to use any guide coordinates this time. I'm going to follow the pattern of up 1 over 2. And now you can see that the POI is there. So that's my first graph. And now when I describe it, I'm describing the slopes. The slopes in this case are different. And the y-intercepts are also different. How many POIs, or points of intersection, do you have? You have 1. And to name this situation, the lines are intersecting, so I'm going to call it intersecting. In math, we don't often come up with complicated names. We generally name things exactly what they are. So down to my second set. My second set is nicely set up. I've got it in the correct format. So b in this case is 4, m is 2. In my second equation, b is negative 3, and slope is 2, or 2 over 1. So my first equation, plot 4, graph alphabetically, up 2 over 1, up 2 over 1, and graph your line, following the pattern all the way through. If you want guide coordinates, go ahead. Or if you can see it, you can then draw your line. The second equation starts at negative 3. That's your y-intercept. And slope is up 1 over 2, up 2 over 1. I said it backwards, but I did it correctly. Up 2 over 1. And draw your line all the way through. Again, following the same pattern. And you should get a pair of lines that are parallel. The slopes in this case are the same. The y-intercepts are different. How many times do these two lines meet? They don't. Name this situation. Well, we have a pair of parallel lines, so we're going to call it parallel. And down to our last pair of equations. The first equation is not in the correct form, so I'll take it up here and manipulate it. I'll push the x to the other side. It becomes negative x plus 3. So in this case, b is 3. And slope, you have negative 1x, so that would be negative 1 for your slope. And just to have rise over run, I'm going to put negative 1 over top of 1. My second equation, I'm going to just sketch it out underneath here, put the x to the other side, isolate y by dividing everybody by 2, and I'm going to get y equals negative x plus 3. Well, that's the same equation as the first one. So I'm going to graph that line twice. My y-intercept is 3, slope is negative 1, run to the right 1, and you can see that it's just going to go through each of the grid marks all the way down. So I'm going to draw my nice line all the way through, and there we are. And to illustrate the second line, I'm just going to choose a different color and go over top of it. So this is my second line. So I've now graphed both lines. So now when we go over to the describe box, the slopes are the same. The y-intercepts are the same. They meet all the time. So they meet in an infinite number of POIs. Name this situation. Well, we have two lines that are in the same place at the same time. So the name we came up with it is coincident lines. And now you know the three possible solutions to a system of equations. To practice this skill, I came up with an activity. So each one of the circles has a pair of equations, as systems of equations, or words that describe a particular situation. And again, you can pause the video and do it on your own, or watch me do it. But if the pair or the words happen to illustrate an intersecting situation, put an I. If they're parallel, a P. And if they're coincident, a C. So in my next slide, I'm going to show you the strategy that I'm going to use, and then I'll show you the answer. So my strategy is to always put your equations into y equals mx plus b, because that gives you the information that you need. That will give you slope and your y-intercept. So my first equation, my first illustration, is in standard form. I'm going to isolate the term with y. So that gives me negative 3y equals negative 2x minus 9. And then I'm going to isolate y by dividing everybody by negative 3. The negative 3's cancel, and you get y equals, a double negative is now a positive, and a double negative is a positive. So that's mx plus b. My second equation, it isn't in standard form, it's in no form whatsoever, it's just jumbled up. So I'm going to move the 3y to the left, the 5x to the right, the signs switch as those terms cross the equal sign. Again, dividing both sides by negative 3, all the terms. Negative 3's cancel out and become 1. The double negative becomes positive, and the negative that is underneath now goes in front, and you have it in the correct form. So if I were to consider those two terms together, I have different slopes, therefore it is intersecting. Okay, so that would be an I. Intersecting lines do not have to have the different slopes and different y-intercepts. If you look at a graph, you could have a situation where they cross anywhere. There's your POI, so those are different slopes, different y-intercepts. But you could also have a situation where the lines cross on the y-intercept, so you would have different slopes but the same y-intercept. So when you're looking at intersecting lines, what you want to remember is that you just have to have different slopes for the condition to be true for intersecting lines. And now here's my solution page. So for each one of these circles, if I needed to, I made some further alterations to the equation. In the first example, the slopes are different. Even though the y-intercepts are the same, that would be intersecting. For the second example, same slopes, different y-intercepts, that would be parallel. And here, my third example, you can see that I've got a purple equation in the middle. And this is just to illustrate that both the first equation and the second equation reduce to the same equation, therefore being coincident. But if you look at the second, the one underneath, it's simply 3 times the first. It's scaled up by a factor of 3, therefore it's the same equation, the same line. It looks different, but it is exactly the same line ultimately. Here, a bit of a trick, I have the same slopes. Negative 2 is b in the first one, and positive 2 is b in the second, so therefore they are not coincident, they are parallel. Those are 2 different y-intercepts. And you can sort of pinch in on your screen to see the different solutions for each one. If you see an equation in the middle, that means it's coincident. If you see an equation in purple underneath an original, I've just altered it to look like mx plus b, so you then can compare the 2 equations. I hope that was useful to you. Thanks for listening. Bye for now.